In this question, you can see that there is a man which starts swimming from this point at t is equal to 0, and he wants to reach this point B, which is directly opposite to point A. His velocity in still water is 5 and the width of river is 48. The velocity of river u varies with the time by this relation t by 2, u is equal to t by 2, and he always tries to swim in the particular fixed direction with respect to river flow. We have to find out that at what angle with AB he should make the strokes and the time taken by the man to cross the river and the trajectory of the path. So you can see that the velocity of the river is variable here, and you can easily analyze that if we find out the acceleration of the river, then it is du by dt, and therefore it would be 1 by 2. So you can visualize this problem that there is a ball which we have thrown like that, and gravity is acting in this direction, and acceleration due to gravity is half. So this would be a projectile motion path, and the velocity of this ball initially was 5. So let us suppose that it is 5. U is 5 initially, and ax, in fact in this case this is y, so ay would be 0 and ax will be equal to 1 by 2. Okay, this is 1 by 2. Now you can see that the range of this path should be 48. So 48 should be equal to 2u square, which is 25 into sine 2 theta by g. But instead of g, we would use the acceleration which we have already written, which is a by 2, which is ax, which is 1 by 2. So this would be 1 by 2. So you can see that it is equal to, and there would, it is, this 2 would not be there, so it would be equal to 24 by 25. So sine 2 theta is equal to 24 by 25, and it is given that sine 2 theta is sine inverse 24 by 25 is 74 degree. So 2 theta is 74 degree, so theta is 37 degree. Now we know that there are two angle of projections for which the range is same, so therefore first angle is 37 and the second angle is 53. Okay, now the time of flight. So time of flight for this first angle would be 2 into u, which is 5, and sine 37 by a, which is half. So this is 20 into 3 by 5. So it would be 12, and the second time t2 will be equal to 2 into 5 into sine 53 divided by a, which is half. So it would be 20 into sine 53, which is 4 by 5, and it is equal to 16. So the two times will be 12 and 16. Now let us find out the equation of trajectory. So equation of trajectory would be simply the equation of trajectory of parabolic motion, projectile motion. So we know that the equation of trajectory can be easily calculated by eliminating the time. So let us first of all see that the distance traveled by this in this direction, in y direction, is first of all, this is u, and this angle is 37, and this is y. So u cos 37 is equal to y upon t, and u is 5, cos 37 is 4 by 5, it is equal to y upon t. So t will be equal to y upon 4. Okay, and in x direction, in backward direction, but positive x is in this direction. So let us suppose that its coordinates is somewhere minus x. So minus x will be equal to u sine 37, and this u sine 37 is also in the negative direction. So this is minus u sine 37, and the acceleration is in positive direction. So this is plus half into t square, and this is also multiplied with the time t. So x will be equal to, u is 5 and sine 37 is 3 by 5 into t. This is minus 1 by 4 t square. So x is equal to 3t minus 1 by 4 t square. So if we substitute the value of t, then it would be 3 by 4 into y minus t, in fact y square by 64. So this is the equation of trajectory. Now we move on the next question. In this question, you can see that there is a swimmer which can swim with a speed of v0 in still water. He is trying to cross the river in shortest possible time, which is the fact that he would be trying to swim in this direction, which is perpendicular to the river. But due to the river, he would be drifting. So there is a new type of river velocity which is variable with this width w, with this distance y. Okay, so it means that if we are standing at this point, then speed of river would be greater. Okay, so this swimmer, we have to find out the equation of trajectory of this swimmer if he starts from origin. We know that he is always trying to move in this direction with the velocity of v0, and the river velocity is v0 w by v0 y by w. So let us see that the y coordinate of this swimmer will be due to this velocity v0, and y would be equal to v0 into time t. Okay, now its x coordinate would be due to the river current, and therefore the river velocity is equal to vr v0 y by w. So let us substitute the value of y. So it would be v0 into v0 square t by w. So this is the river velocity. So we can write down this river velocity as dx by dt, and dx by dt is equal to v0 square t by w. So x will be equal to v0 square t square by 2w. This is x. So if we eliminate time, then time will be y by v0. So x will be equal to v0 square into y square by v0 square divided by 2w. So cancelling v0 square, x will be equal to y square by 2w. So the correct answer would be option 2. Okay, now let's move on the next question.